Alright guys, today we're going to be doing a rate of change in radians per second problem. This will be our problem. A 30-foot ladder is leaning against a wall of a house. If the base of a ladder is being pulled away from the house at a rate of 3 feet per second, how fast is the angle made between the wall of the house and the ladder changing when the ladder is 24 feet from the house? So to start off, I'm going to do something that was always helpful for me. I'm going to go back and reread the problem, but this time I'm going to be pulling the information that I need. So let's take a look. Alright, what we need to know is the ladder is 30 feet. We also want to know that it's being pulled away from the house at a rate of 3 feet per second. It's important that we know that it's the angle made between the wall of the house and the ladder. We need to know that what's changing so that we can solve for that. And we have to know that the ladder is 24 feet from the house when this is happening. Alright, so let's do a picture because it's really helpful. So here I've got the information pulled out I found the most helpful. Got our 30-foot ladder, which will be this value right here. Let me just stick a text box around that. We have that value right there. So this is going to be 30. If we take another one, we can look over here. This is going to be our x, but it's also equal to 24 feet. What we don't know is what this value right here is, our y. Alright. Fortunately, since we have these two values, it's pretty simple to find that. Just Pythagorean theorem, which is, a squared plus b squared equals c squared. So here, I got it started. 24 squared plus y squared is equal to 30 squared. Just solve for that. Simple stuff. We get y equals 18. So now that we have that, we can write that in. Alright. So here we've got our values labeled. And we're going to start by saying that dx dt is equal to 3 feet per second. The reason dx dt is equal to 3 feet per second is because our 24 right here is also an x. And we know that x is changing at 3 feet per second because the ladder was being pulled away from the house at 3 feet per second. So let's start with some of the more problematic stuff. What we've got to do now is we've got to find this angle right here. This theta is what we're going to call it. I'm just going to write theta. And we've got to solve for this. So what that means is we also need d theta dt. And because we know that we're solving for something like that, we know we're going to have to include a trig function in there to find that angle. So let's get started. We have to find d dt of sine of theta is equal to 1 over 30 times x. The reason we can do that is because we know that 24 is our x value for this. So we simply just took the x out of that equation and we're going to multiply because x equals 24. But the reason we didn't do sine of theta is equal to 24/30 is because it makes it easier to take the derivative. So here I did that. We have cosine of theta is equal to d theta dt. The reason we got that is because it's a trig function with part of a chain rule. We took the derivative of sine, which gives you cosine of theta, and then with the chain portion, you get the derivative of theta to respect the time, d theta dt. And then on the other side of the equation, we did the same thing, where we got 1 over 30 times the derivative of x in respect to time, or dx dt. So let's keep going down. I'll do some stuff. Here we see that cosine of theta is equal to 18/30 because theta is right here, so adjacent times hypotenuse, which is equal to 1 over 30, and dx dt, as previously stated, was the 3 feet per second because that's what's changing right here. So if we come down here, we're going to start canceling some stuff out to get the d theta dt all by itself. So we're going to start by just multiplying 30/18 across the entire function. Once we do that, this crosses out and we get d theta dt is equal to 1 every 10 seconds times 30/18. The reason we don't have a unit is because since we're solving in radians, it makes sense that somehow our unit's going to cancel. So we come down and we get d theta dt is equal to 30 nothing over 180 seconds. We simplify that to get d theta is equal to 1 radian every 6 seconds. And that would be your rate of change for theta, which would be right there.